Hello, Team 8-1, Alley Cats. Today we are going to be working with equations where we see variables on both sides of the equation. Won't that be interesting? You can find problems like this in the book on page 134. So I can solve equations with variables on both sides is our I can statement. Goes right along with our title. So really, before we get started, we want to remember that there are certain procedures that we follow. We want to make sure that we have taken care of any parentheses. We're just going to use the acronym PLMS. That we have taken care of any parentheses or grouping symbol. L is for like terms, which means to add like terms on the same side of the equation. The M would be what we're really dealing with today, and that is when you have variables on both sides, or move. And then the S, of course, is to solve. So what do those stand for again? This is going to be parentheses, combine like terms, move, meaning variables on both sides, and then, of course, solve, meaning that we are at the place where we have a two-step equation. So with one step, and that is what's going to happen in this problem, with one little step, then we really are right back at a two-step. So I see that I have a 6x on the left, and I see that I have an 8x on the right. So really it's a matter of opinion which one I choose to move, but that is going to be our starting point. 9 times out of 10, I'm going to choose to get rid of the variable that's on the right, just because when I'm finished with my equation, I want the variable to be on the left. So I might as well start there. So I'm going to go ahead and get rid of 8x on the left. Notice that I'm writing subtract 8x. Whatever I do on the left, I also do on the right. So I end up with negative 2x plus 3 on the left. 8's go away. That was the point, was to get rid of 8x, and now I can solve my two-step equation. Divide through by the coefficient. X is equal to 12. Now, what does the 12 mean? The 12 means that if I were to go back and substitute in the 12 in the equation, that the left side of the equation is equal to the right side with a 12. So you could go back and substitute that in and find out that it does, in fact, satisfy both sides. But that just means that the left is equal to the right. Moving on to number 2. Oh my goodness, that one's up there tall. I think I can handle it. Remember our P, L, M, S. So if we have parentheses, we have to take care of those. I don't see any parentheses. Do we have like terms? Well, not on the same side of the equation, we don't. How about the M part? That would be move, and that's what we're going to have to do because I'm sure you see this also. We see 6D on the left, and we see a negative D on the right. So that's going to be the first step, is just to get those together. So as far as kind of your thought process, if 6D and negative D were on the same side of the equation, we would just treat that like combining like terms. But because they're on opposite sides of the equation, that's why we have to use opposite operations. So to get the negative D to the left, and once again, you could get rid of 6D on both sides. I just opt to get rid of the one on the right because then I know that's going to leave my variables on the left. So I'm going to go ahead then and get rid of a negative D by adding D on the right. Whatever I do on the right, I also have to do on the left. And if it helps you, go ahead and put that 1 in so we make sure that we combine those terms. All that's left on the right is negative 7, 14, plus I'm working backwards. 6 plus 1D is going to give me a 7D. To solve for D, we want to isolate the variable or get it by itself. That means to subtract 14 on both sides of the equation. That's going to go away. 7D equals what? Negative 21 divided by 7. D is equal to negative 3. And once again, if you went back in and substituted, then you would see that both sides of the equation satisfy or are satisfied. Let's go ahead and do that. 6 times negative 3 plus 14 is equal to negative 7 minus, don't forget that the value of d is a negative 3. So let's see how that works. We end up with negative 18 plus 14 is equal to, this is really negative 7 plus 3. So we end up with what? Negative 4 is equal to negative 4. And that looks good to me. It's exactly what we're looking for. It satisfies where negative 4 is equal to negative 4. That is a true statement. If I get down to the bottom and it says negative 4 is equal to 7, obviously something went wrong and I can go back and recheck my math. All right, so here we are with number 3. PLMS. So parentheses. So the first thing I have to do is make sure that I don't have any parentheses. So I'm going to have to just bring down my left to start with. That's all I want to do. And then on the right, I have 5 times 0.8. So 5 times, we want to make sure that we are distributing. I'm just going to distribute underneath because I can't really reach that. So we're going to say 5 times 0.8, which of course gives us a 4. Don't forget the n. And then 5 times 2 gives us a 10. Now, as far as eliminating a decimal, is concerned, I only see one decimal in the equation. But let's go ahead and tackle that just so we have more practice. Remember that the number that has the decimal, in this case we only have one decimal, then that means we are going to multiply both sides by 0.3 times, what, 10? Because I'd only have to move the decimal one place in order to get rid of the decimal. So that means big parentheses on the left, and, you guessed it, big parentheses on the right. So we end up with 3n minus 80, which is equal to, don't forget to distribute. Let me show you where that came from, just in case you're wondering. 10 times 10 and 10 times 4n. So we end up with what? 40n plus 100. Now, from this step, we can solve by combining our terms. So now we're at the move step where I see variables on both sides of the equation. So we're going to subtract 40n on both sides. What? Negative 37n minus 80 is equal to 100. Add 80 to both sides. Negative 37n is equal to 180. And I end up with not the prettiest of decimals. I've got what? A negative 4.864 repeating. So if I can avoid rounding, I'm going to avoid rounding. So in other words, this is what you see in your calculator. And then I'm going to run out of room here, 864. So that part of the decimal is repeating. Final answer. Hopefully you're starting to feel a little bit more comfortable with eliminating the decimal in the equation. All right, so I see here there are parentheses, excuse me. So that's the first thing that we're going to take care of. The parentheses, we want to make the parentheses go away. The only way to do that is to distribute. So what I would suggest doing right now is stopping the video and working on both sides of the equation, and go as far as you can. Go as far as you can with the equation. You're going to end up with variables on both sides, and then just see what you can do with it. So go ahead and stop the video and try to do that on your own. All right, so I'm sure at this point you've sort of figured out that there is no solution. Let's talk about why there's no solution. So it doesn't mean you did anything wrong. In fact, if you got no solution, you know that you've done it correctly. Once I distribute, then I have a kind of a red flag going up right here in this step. This says 16f minus 24 is equal to 16f minus 32. How is that possible? How can I have 16f and subtract 24 on the left and have 16f and subtract 32 on the right and end up with the same answer? From there, it just really doesn't make sense. But let's go ahead and carry this out, because let's say you get to that step and you're like, okay, I think it's no solution, but I want to be 100% sure. So the rule is then to subtract 16f on the right. Whatever you did on the right, then you went over here and did on the left. And look what happens. My 16s cancel, and I end up with negative 24 is equal to negative 32. Well, we know that that simply isn't true. When the left is not equal to the right, we call that no solution. So when you get down to this step, that's good, but make sure you just take it one more step and you say no solution. What that means is there isn't a number that I can substitute in for f to make the left side equal to the right. You are going to see some no solutions on your work today. All right, PLMS, PLMS. I don't see any parentheses, so I'm going to check that. On the right side of the equation, I do see like terms. And remember, this is just a two-step equation, or leading to a two-step equation, I should say. We want to combine those terms that are alike, negative 4 and positive 3. That's going to give me a negative 1, and then plus 4b. And right away, right now, your brain should be saying, okay, well, I've got a 4b on the left, and I've got a 4b on the right. Ooh, I've got a negative 1 on the left, and I've got a negative 1 on the right. So that, to me, tells me it's basically the same thing. But let's go ahead and finish out this problem, carry it out so we can see the last step, and I want you to do that as well. I want you to take it down until you have one number on the left and one number on the right. So we know that we have variables on both sides of the equation. So we're going to subtract 4b on the right. We're going to subtract 4b on the left. Okay, those are gone. And oh, now I have negative 1 is equal to negative 1. Is that true? Is negative 1 equal to negative 1? Of course it is. So that means that we call this identity. What does identity mean? That's when the left is equal to the right. And the left is equal to the right, we call that identity. You might hear infinite many solutions, mean that the solution set goes on and on and on and on, or maybe just many solutions. All of those are possibilities. For today, we're going to concentrate on identity. It's kind of like a mirror image. When the left looks at the right, we end up with exactly the same answer. And that looks like it's going to do that for us for solving equations when we have variables on both sides. Thanks for watching.